One of the things you need to learn from here is water demand is a function. It's not just a number or numbers. What does that mean? Well, water demand is a representation of the value of water to different users. So demand is a reflection of value. You could distinguish between different users, and where does that value come from? Well, if I am a person, I'm willing to buy something, it means I am willing to pay for it because of the utility and consumption, because it makes me happy, it makes me satisfied. But if I am a company, which in this case, when we say a company, a firm, a producer, it doesn't mean just a corporation. It could be a farmer, it could be anything, anyone doing production, then we are talking about profit being behind the value. So I buy something to use in my productive activities because that thing I am buying is going to increase my profits. So the value I have for the item is coming from production, from the desire to maximize profits. This is standard stuff. What does the demand depend on? Well, it depends on many things, but one of them, and always when you think of demand, there is one important variable, and that is the price. So to an economist, demand is a function of a price or prices. That's very important. What else goes into the demand? Well, when somebody is choosing how much water to buy, there is not just the price, but there are other things that affect. My demand for ice cream will depend on what? It will depend on the price of ice cream, right? What else? The budget, my income or budget. What else?
Utility,
yes?
how much utility compared to how else I would spend the money I gain from the ice cream.
Yeah, so in economics we say preferences. So some people will prefer ice cream, so they will tend to buy more. Some people don't. What else?
The weather.
Yeah, the season is important. Okay, you don't go looking for ice cream in July. Well, kids will always, anytime, right? So there is a lot of things that are behind demand. And if you are looking at a producer, it's going to be similar in the sense that if I am a farmer, my demand for water is going to depend on what? It's going to depend on, one, what type of production system I have, the technology, what is possible for me, what do I need the water for, what am I growing, and what crop. Does that crop respond to water? Do I need water for it? Does it respond a lot, very little? That's all important. It's going to depend on the prices of the things I use in production, which is inputs. So if nitrogen is cheap, what am I going to do? I am going to be encouraged to produce more, which means I will need more water, and so on. And output prices. If crops are profitable in terms of revenue-wise, then I am going to expand my production. I am going to be willing to buy more water. All these things are important, and generally when we think of a production, always want to say output or Y is a function of the technology, the amount of water, and the amount of inputs you can use. So in the case of a farmer, a technology is whatever production system I have. This is more about the agronomy and the engineering and so on that I use to produce. For we are talking about irrigation water. So how much water I want to pay for or extract or save. X is the production input, so it's nitrogen, labor, capital, and I'm doing this. That's my business. My business is to transform the water and inputs into output. And the way I think about my problem is I have no interest in maximizing output. That's not for me. A farmer doesn't say I am going to maximize output, because when you expand output, costs also go up. So you are interested in maximizing profit, which we write as pi most of the time, and my profits are the difference between revenue and cost. Revenue is price of output times my output, and cost is the sum of all the cost items, and that's my optimization problem. If I am thinking of water as a separate item, then I have to also subtract the cost of water I apply. So whatever I pay for the water, or whatever I pay to get the water and also to apply it, has to be in the cost. So how do we maximize profits? Well, to maximize this by choosing inputs. So is this familiar to you? Yeah. If you take the first derivatives and then set them to 0, in the case of water, it's going to give you something like this, which says the value marginal product of water should be equal to the cost of water. So what I am willing to pay for water, which is the value marginal product of water, that the value of water to me as a production item should be equal to what is going to cost me to get the water. Okay? What happened? This is just another way to look at that, but we don't have to do this. You are familiar with this. Okay, what do we have here? If you were in my production economics class today, this would be another example. So if I have this, and if the price of water is 300, of wheat, sorry, and the price of water is 100 per unit, and labor is 120, how do I maximize profits? So I have a production function, Cobb-Douglas. The reason I don't say Cobb-Douglas here is because in the water economics unit, no one cares what Cobb-Douglas is. It could be engineering students or environmental science students, they don't care who Cobb-Douglas is. It's only economics students who care. But it's the Cobb-Douglas function. In this case, what we have is our output is Q, and our A is 2, and our first input is water with an exponent of 0.4 and labor. So how do I maximize this? Well, to maximize this, I need to set up a profit maximization problem. So that means my profit, let me see what I have in the next slide. Do I have, so that I use the same style? Okay, my profit is going to be the price of output times the quantity of output. I am going to spell it out here. And then I need to subtract, that's my revenue. Then I need to subtract my cost, which is, now if you are new to this sort of things, the first thing to establish is, okay, this is the quantity I want to optimize, but what am I choosing? What do we call that in economics? We call that choice variable. Your choice variables in here are the amount of water and the amount of labor you use. So how do I optimize this? Well, I need to find the levels of choice variables where my profit is no longer responding to change. And that means the derivatives have to be 0. So that's what we call the first order conditions. So what do we have here? We have two variables, two equations. Do we know how to find the solutions to this? You are going to end up with something like this, and you can find what the optimal water demand is and what the optimal labor demand is.
Yeah, but should we learn that for the quiz?
What you will have is a relationship between prices and demand, and behind it will be also the nature of the technology. We are able to tell stories about what people are likely to buy in terms of quantity and how that changes with price. What else could we do with this? Well, economists have this concept of consumer surplus, right? What's a consumer surplus? Consumer surplus is what you are willing to pay over and above what you are actually paying. If I am willing to pay 17 for a hamburger and I go to the guild and the price is 5, what's my consumer surplus? The maximum I'm willing to pay for the hamburger, which means the value I put on the satisfaction of having the hamburger is 17. But in the market, I am paying only 5. 12 is my consumer surplus. Okay? So you got to protect your consumer surplus. That's the benefit of consumption, right? So any policy that takes away the consumer surplus from you is hurting you. So you could do that, but when you have a demand function, you can see how things change, whether a price has a lot of effect on demand or not. Shift in demand, this is something that's happening because of not the price of the water itself, but the price of something else. What could shift the demand? Well, season. Okay? In winter, you don't want water alone, so demand curve will shift in. Okay? Aggregation, let's say we know somehow by using models or by simple guessing or something, we know what individuals are willing to consume. How do you go from there to market demand? Okay? So I have the residents in Paris. I want to know the aggregate demand. What do? I have to add up the demand, right? Okay? That sounds simple. I have to add up the demand as long as water is rival. If it's rival use, I add up. So if I know what each one of you wants, then to know the total, I know whatever I give to one isn't available to someone else, so I need to sum up things. But if it's non-rival use, like environmental use, I shouldn't do that. So if I go back to the street light example from earlier, if each one of you wants one street light somewhere here, collectively you all want one, not 7, right? Because that one is available to each of you. So if it's non-rival, the same thing is available to everyone. I have to take that into account. If we want to know the value, we have to know the aggregate demand. If you are aggregating demand, there are some things to be careful about. I already mentioned rival versus non-rival, right? That's obvious. Okay, so if you are demanding water for fish in the rivers, that's a non-rival use. I shouldn't add up your demand levels. Another thing you need to be careful about water is reuse. Reuse means the same amount of water gets used again and again. If farmer 1 is taking 2,000 megaliters of water, what happens to the water? They use it here? Is that the end of the story? No, some of the water will come back to the river. It's what's called return flow. So that means that farmer isn't actually using what they appear to be using. I should take into account that some of the water that appears to be demanded by this farmer is actually available again. So that's reuse and return flows. Another thing to consider is, well, water delivered in different places has different costs, different processing requirements. So when we are trying to allocate things, we have to take that into account. Are important. We can skip this. I have already told you what it is. Please read. Rival demand. So if it's rival, we need to know what everyone is willing to buy at a price, and we have to take the total. If it's non-rival demand, it's better to start with the quantity and then figure out how much people are willing to pay for it. There are charts in here which say the same thing. So if I have 2 agents and if it's rival, well, I need to figure out. So the first agent is willing to pay for small amounts more than the second one. That's why they have higher values here. But their values dies off quickly, so they don't need a lot. They just quickly get satiated. If I am going to take the aggregate demand, what's happening here? Well, I need to think in terms of price. What happens as the price changes? If the price is up here, no one is buying. If the price is down here, only agent 1 is buying. Agent 2 is out of the market. When the price is low enough, agent 2 will be active. To know what the aggregate demand is, you need to say, how much could I sell at 17? How much could I sell at 15, 10, and so on? You go down, right? That's rival. So I sum up and I get this kinked curve. That's fine. If I am thinking of a public good, I need to think in terms of what the good is worth to the group. So I start with nothing and I say, how much would these 2 individuals be willing to pay for a small amount? Well, if I have a small amount, both of them are willing to pay something. D1 is willing to pay higher, but I need to add up both of them. So I am going to end up with a price that's up here, because on top of what D1 is willing to pay, I have to add what D2 is willing to pay. I have to pile them up, right? Another example, we can skip non-rival use. If you have demand curves in economics are generally written with the price on the y and the quantity on the x. So that's what we have done, but it is a demand curve. How do I find the aggregate demand? If it's rival, how do I find the aggregate demand? So that's the demand. If it's non-rival, you can do this at home. You need now to think of quantities and then adding the value. Then you can find the aggregate demand, and that's going to be what you have here.